Welcome to RCR Wireless News. I'm Martha DeGrasse, and our topic today is investing in HetNets, network planning, optimization, and return on investment. I'd like to introduce you to your panelists for today. Paula Dublin is Assistant Vice President for Construction and Engineering at AT&T. Paula, thank you very much for being part of our webinar today.
Thank you, Martha. It's great to be here. Thanks.
Thanks. Analyst Simon Saunders is Director of Technology at RCR Wireless, and he joins us today from the UK. Simon, thank you very much for being here. I know it's late in the day for you.
It's a pleasure to be with you at any time of day, Martha.
Thank you. And Scott Sumner is here representing one of our sponsors, Heterogeneous Networks. Scott is VP of Solutions Development and Marketing. Scott, thank you very much for being here.
Yes, thank you, Martha, for having me on the panel.
Another sponsor today is CommScope, represented by Philip Sorrells. He is Vice President of Strategic Marketing. Philip, thank you for being here today.
Thank you, Martha. It's always a pleasure to be with our friends at RCR.
Well, we're glad to have you. And Ixia is a sponsor today, represented by Daniel Musat. He is Senior Technical Marketing Engineer. Daniel, it's great to have you on the webinar.
Thank you, and hello, everyone. It's great to be here.
Thanks, and I'm Martha DeGrasse, Editor at RCR Wireless News. A quick word about RCR Wireless News. We are a premier news source for the wireless communications industry. We cover carriers, networks, devices, test and measurement, and telecom software news. Follow us on the web at rcrwireless.com and on Twitter at RCR Wireless News. Now, before we begin the webinar, I'd like to quickly call your attention to a feature report on our website on investing in HetNets. You can download this complimentary feature report from the RCR Wireless homepage. Click on the Reports tab at the top in the middle. Key takeaways from this report: carriers continue to invest actively in DAS. Small cells have been less quick to take off, but they are starting to. The increasing cost of spectrum is making DAS and small cells relatively more attractive to carriers as an investment as they look for ways to get the most out of the spectrum they have. Vendors are finding ways to help carriers with outdoor deployments by identifying sites as well as power and backhaul resources. And network optimization can significantly impact the ROI for HetNet deployments. Again, you can download this complimentary report at the RCR Wireless website. Now, at this time, I'd like to turn it over to analyst Simon Saunders for a brief introduction to our topic. Simon?
Yeah, thanks very much indeed, Martha. So just to introduce my firm, RCR Wireless, to give you context, we're a firm of independent wireless advisors based in the UK but working internationally for operators, regulators, and vendors in the wireless industry, but also working very heavily in the community of vertical industries that depend on wireless, including big venues like stadiums. We've worked across a wide range of technologies, and I founded and chaired what was Femto Forum and then became Small Cell Forum over a number of years, and today we're helping a number of our clients to make small cells very real in a variety of places. So I wanted to say a few words about what I see as the situation we find ourselves in with HetNet HetNet cells of various types and the challenges we encounter. And I've set out here the 5 environments in which we see HetNets being deployed. And each of those brings a different situation and challenges. So in the home today, small cells, if you like, very much started in the form of femto cells in the home some years ago. Today, a lot of people are asking me whether the advent of voice over Wi-Fi and Wi-Fi calling means that home femto cells are dead. Interestingly, actually, the volumes being shipped have been rising very rapidly and have reached about 10 million now. The volumes shipped are being dominated today by kind of inside-out operators with limited spectrum or a limited network that actually want to build out using femto cells. So they're in fact driving quite a substantial new business. And the relevance of that to everybody else is that it drives the price of chips and of software down. And that benefits HetNet as a whole. So I'd say that there was a good reason for everybody to be interested in femto cells still. Most people, though, talk about small cells today. Most of the light and heat is around urban metro cells, if you will. And there I think we need to really examine what the motivations are. Most people talk in terms of the kind of pain relief aspect of taking an aspirin of urban small cells to solve a capacity problem. And that's very necessary. You know, everyone needs some element of that, but I'd venture that it's far more relevant to get some real competitive advantage from your small cells, to deploy them to deliver more consistent services with a better user experience, and really, really speed up your network and use that as a very positive tonic rather than just dealing with a headache. What that leads us to is just how many small cells you need to deploy to meet each of those needs and where you're going to deploy them. And whereas the good old-fashioned radio planning rulebook is very well known to everybody, I think the planning rulebook for small cells still has to be written. We're still learning the design rules linked to the business case there. What we're also finding is that once people have acquired their urban small cell sites, there's increasingly a question as to what should actually go on those poles. Should it be conventional distributed small cells, or should we be looking at a CRAN architecture? And that depends very much on your access to and costs of getting the transport to those locations, so the backhaul or front haul question. In the enterprise, we see vast latent demand. Many enterprises mobilizing their operations and dissatisfied with the level of coverage and service they get. And those places are relatively underserved by any other means, and less than 2% of enterprise buildings actually have an indoor coverage solution today. Now, the economics of providing dedicated indoor coverage are utterly transformed by small cells, and we've recently done some detailed work on the use of Cloud RAN-based small cells compared to DAS-based solutions. And to many people's surprise, we found that those Cloud RAN-based small cells are very much more cost effective, even in a multi-operator situation. But I think the real challenge there is whether operators can scale the deployment through their traditional processes to the industrial scales needed, or whether a kind of Wi-Fi style model is needed where enterprises fund and perhaps actually install and plan the deployment for themselves. In venues like stadiums, DAS remains a very important workhorse, the go-to technology. But we are seeing places where we just can't install enough DAS antennas to sectorize tightly enough to reach the capacity demands over the coming years. Wi-Fi gets used a lot for offload, but we find that in these hyperdense environments in a stadium bowl, it often underdelivers in terms of experience. But this is probably the dream use case for a CRAN, coordinated multi-point architecture. And last but not least, people often forget about the rural applications of small cells to bring coverage to places that just haven't been cost effective in the past. It's challenging to build the business case and get the backhaul in there, but we do see scope for doing that via a variety of means, including satellite backhaul. It remains a difficult area for operators, but we've recently done a global analysis of the costs of rolling out to hundreds of millions of people that don't have mobile broadband coverage, and we see $1 trillion opportunity for society, and operators that get behind that can be real heroes, as well as building a great loyal customer base for themselves. So a good range of interesting situations for us to debate there, I hope, Martha.
Right, thank you very much. And you're right, that is going to be a very, very important issue for people who don't even yet have access to mobile broadband. Thank you. Paula, at this time, I'd like to turn it over to you for some first-hand insight into how carriers evaluate the HetNet investment. Paula Dublin of AT&T.
All right, so investing in HetNet. So if we could advance a couple of slides over, that would be great for me. So the most important thing to AT&T and most carriers, at this point, is finding the right solution in a HetNet world. And there's certainly not one size fits all. There's many parties that are involved in here, including the consumer, including cities and communities, and of course the carriers themselves and that sort of thing. So I think it's important that we recognize all the tools that are available in the toolbox, and understand which is the more applicable, solution for the challenge that you need to solve, and understand that. One of the things that that I believe is much a self-inflicted wound by the industry itself, and that and that includes the carriers, that includes the OEMs, is that a solution is developed, or let's just call it that. A solution is developed. It's ahead of its testing model. It is put out into the market space. People get all excited about it, and then they're expecting deployments to happen, almost immediately. Well, we all know that that's not the case. So we have to keep in mind one of the things that's probably the bigger challenge of all solutions out there is, will the community adopt the infrastructure or the hardware that is necessary for the solution? And so size means a lot here. And then also, as a carrier, we have to take into consideration, all the aspects of site acquisition, whether our solutions be a macro, whether they be a DAS, whether they be a Wi-Fi, whether they be a small cell, or the next great thing. Site acquisition is always going to be a part of it. Site acquisition can be expensive. So from a commercial power perspective, how do you power the network? How do you power the solution? That can also be expensive. Backhaul, always a challenge, always will be. And then, of course, there's interoperability. And then there is alarming and maintenance. And then, of course, the customer service. We want that absolutely excellent customer experience that goes along with a great network or a great HetNet. And then, of course, there is the technical skill requirements that are necessary to maintain that network. So those are some considerations around HetNet that all of us, every one of us on this call, have to take into consideration. So what the evolving HetNet looks like, it is a video first, for AT&T, it's a video first architecture. It must be agile. We must simplify processes. We got to get to standardized platforms. The customer interaction has got to be effortless. You can't bog a consumer down. You can't bog a customer down. You can't bog an employee down with systems, processes, and platforms that don't serve. And then really excited about the user-defined network cloud, and then of course a skilled workforce. All of us always seek really good people who are committed and who are involved and who are passionate about what they're doing. We see the skilled workforce, in areas of software. It's very quality intense. It's about, communications and service, both to fellow employees, to vendors, to suppliers, but most importantly, customers. And then of course the skilled workforce has to be applications rich. So either in the way that they specify requirements, or whether or not they create applications, or whether or not they take and they make the applications that we already have, make them even better. So HetNets take all this, have to have every one of these components, if they are to be successful, as I know they can be.
Terrific, Paula. Thank you very much. I think that you and Simon have laid the groundwork for a great discussion here today. Before we get into that, we're going to have the chance to hear from each of our sponsors, starting with CommScope, Philip Sorrells.
Thank you, Martha. So our perspective is a little bit unique in the fact that, as our core expertise here and our core value prop that we bring to the market is the implementation of RF. So CommScope in and of itself doesn't manufacture or design radios. We design the infrastructure and the platforms that allow radios hopefully to work better. So our perspective about small cells is kind of built around the idea of taking a holistic view at how we can develop platforms that apply radio technology in these different applications, all of them aimed at building capacity and efficiency in the network. So clearly, when we look at small cells, we have to solve three big chunks of problems. Large venues, which again we've talked about, DAS is clearly a good, has a good role in large venues and those type of applications. Enterprise buildings are where there's a lot of very interesting discussions around the best way forward in enterprise. So there's some DAS discussions, clearly small cell, many remote radio heads, and an idea that we've developed that we call a unified wireless infrastructure, which is more of a platform approach that is independent of the type of radio, be it either a small cell or a standard radio head. And then, of course, we have to solve the outdoor hotspots with either small cells or ODAS, or a concept that we call mini macros, which is really the same architecture as a macro, except the antenna height above ground is significantly lower than you would tend to have in a traditional macro. Or even in some cases, taking hot sectors or sectors that are facing hotspots in the outdoor ecosystem and just working on how to improve the capacity of that macro. You know, that's another way that we can help solve the small cell capacity problem is really getting every bit out of your existing assets. But no matter how you approach any one of these things, there's four fundamental problems that still have to be solved. And Paula already alluded to them, so I won't spend a lot of time on them, but fundamentally, no matter what application, you still have to solve the problems of backhaul. You still have to solve the problems of where do you put the site and how do you get permission to build that site and what kind of concealment things have to be done and all the variables that go into the complexity of site acquisition. You have to get power to it. And that can be quite a challenge in and of itself. And then ultimately, at the end of the day, the performance from that small cell or that Pico or whatever that may have been needs to have a high enough quality level that it really impacts the overall performance of the network without creating interference. So a very, very important concept to look at. And all four of those have to be looked at despite the radio technology. So those are really non-radio applications. So we believe that the industry needs a good bridge. And what I mean by that is we need a bridge from the architectures that we have today to something that really gets us to simplicity, scalability, and flexibility, which I think Paula will agree to is one of the key things that carriers are all looking for, is how they can make things simpler, more scalable, and more flexible. And to me, that starts with frequency. So the first part of that bridge really needs to be built around a concept that we would call frequency agnostic. So devices that are capable of handling multiple frequencies or having a bandwidth that they are able to provide a very wide bandwidth capability. So that's key, and we'll talk about frequency later on in the call, and it's a very important topic. The solution needs to be intuitive. It needs to take out some of the human element of troubleshooting and of implementation and really make it. And I think that's a very important characteristic. The third characteristic of a great bridge, I think, needs to be built on a standard infrastructure. So again, as we build out this capacity, it needs to be building blocks that are modular and common to what people in that normal ecosystem are used to working with. So for example, in an enterprise building, you would want the cabling system to look like standard IT cabling, for example. That's a good example of a standard infrastructure. And last but not least, it needs to provide dynamic capacity. One of the challenges that we have in this application is that many of the hotspots or enterprise buildings or venues that we're serving, the number of users and the type of capacity demands that they have are very dynamic, and they'll change from one type of event to another type of event by dramatic amounts, really dramatic amounts. So the capacity scaling needs to be able to be done dynamically, and if we can solve and get those four things across the bridge, I think we can really get towards simplicity, scalability, and flexibility.
Excellent. Thank you very much, Philip. At this time, we're going to hear from Scott Sumner of Exedian Networks.
Thanks, Martha. The aspect of HetNets that I'd like to explore here in terms of investment is really making sure that, as we hear from our colleague at AT&T, you have to do this right the first time, and there's a lot of pressure on the performance of the network itself. And part of the problem here is now that we're adding small cells into the mix is that we're adding additional elements into the chain of the backhaul itself, so adding an additional step, adding additional processing, latency, and all this can make achieving the same kind of performance over a small cell more challenging than the macro itself. And you can see here an example just of a standard one-way delay that you would accumulate over a small cell backhaul network, and how it actually impacts some of the expectations for things like synchronization and media responsiveness and voice control and other applications that need to use these networks. And that the latency can easily exceed the requirements if they're not designed properly into the backhaul. And one other aspect that's really challenging for anyone deploying a HetNet is how dynamic they are. So you have self-adjusting and self-optimizing networks. You have cells that can go to sleep to save power. You have the interference from potentially from a macro impinging on the small cell itself as they're sharing the same area and same frequencies. You've got weather-related fade and capacity changes that can affect how the network is loaded in terms of utilization. And you also have very rapid handoffs with these smaller cells in a mobile environment.
Right.
These are some of the challenges that are being faced, and really the idea here is to create a plan and a method to be able to monitor and create a performance assurance method that will support the business case for small cells, but also ensure that they're deployed the first time. So some of the requirements here in a very dynamic network, you need to be able to look at multiple layers to isolate things very quickly. So Ethernet IP layer, as well as a quality of experience application troubleshooting layer where required. Some of the problems that come into play are the need to test over a full mesh-style environment. Now you're testing between a small cell and a macro cell, and maybe between small cells, you have to validate the X2 interfaces. So traditional probing type solutions that would be able to monitor performance and alert you to issues or turn up a small cell at the beginning of its life can't be used to test these mesh-style traffic paths. The other aspect that would normally be used in this kind of environment to turn up a small cell or a backhaul link, for example, would be field testing with a handheld test instrument. But as we know, the traffic loads are going to change very dramatically over times of day. They may change as events happen and so on. So field testing is a good way to turn up a circuit in some cases, but it really only allows you to see something at one point in time as opposed to how things might evolve. And when you look at the evolution towards SDN, towards self-organizing networks, towards dynamic pathing of traffic, as networks move towards this more full fabric as opposed to a core and an access network, this optimization that will be done automatically in many cases needs to have a feed of real-time metrics coming from all parts of the network so you can detect issues but also fix them right away. So I guess the main challenge here is when you're rolling out a HetNet is that you want to have the same level of performance as a macro cell, but using the tools that would normally be deployed, let's say a network interface device, for a macro cell to monitor and assure its performance are cost prohibitive. So the size, the power of your testing solutions, the operational expense has to be sized right to fit the business model of a HetNet and the smaller endpoints that are serving a smaller number of customers. So there's ways to drive the cost out of testing solutions that will be needed to deploy these HetNets efficiently. The key things to keep in mind is it really should be a standards-based solution, so you can use what's already embedded in your network elements as testing methods, interoperable with every type of possible test systems that you have today, and also your network controllers, and open so it can be programmable. And some of the options you would have here, as opposed to the expensive probes and field test sets, would be a NID, which is typically used at a macro site, and then virtualized versions of these, and even software agents themselves that can be much smaller and lower cost, so they can be right sized to these smaller endpoints. So this network embedded instrumentation that's always there, that's very lightweight, that has the same capabilities as traditional test sets, but that's been virtualized and the cost has been driven out and can live there all the time and embed it in the network is really the evolution of how operators can roll out HetNets without sacrificing the performance. So we can take a look here at how the full service life cycle would need to be managed. Basically, the first step of deploying a HetNet would be to do a pre-assessment on your network on the backhaul to assess readiness, to make sure that the infrastructure can handle this additional load on it. So this is an easy simulation to do using these virtualized instrumentation methods. Once that's done, you can deploy the service and then verify that the circuit is turned up properly with the same kind of active full line rate testing that's required. Then ultimately you want to be able to monitor that path in real time from that point onward, as well as the rest of the network, to make sure that there's no changes in performance as traffic levels change and as the network dynamically adjusts. And also, of course, assure the performance over time, so being intelligent in the ways that you can localize faults and find them quickly to make sure that the customer experience isn't impacted longer than necessary, or even predictively if possible. Thank you, Martha.
All right, Scott Sumner, thank you very much. At this time, we're going to turn it over to Daniel Musat of ICSIA. Thank you very much, Daniel. Take it away.
Thank you, Martha. So we've all heard how HetNet bring in new features and opportunities. And one aspect which is, let's say, similar to when LTE has been introduced, it's the multi-dimensional aspect. Because not only we have new devices, like the femto, the pico, the micro cells, we have remote radio heads and the CRAN. We have the security gateways, the eNodeB gateways, and the home eNodeB, and then we have the Wi-Fi offload. So apart from this, we also have the new technology which comes in. So we have the self-organized, we have the carrier Wi-Fi, and then we have other like LIPA and SIP2. So all these together bring new challenges. And the challenges we are seeing from the testing perspective or from implementation perspective, you have more cells, you have a new topology, well, that brings in increased mobility and interference. You have greater power, greater responsibility, that leads to greater expectations from the customers and making sure the quality of experience is as good as it was in the past or as the customers are used to have. Of course, another challenge is planning and optimization, and some of the aspects will be discussed a bit later, like backhaul and timing. And last but not least, interoperability, as multi-vendor, multiple technologies.
Right.
Thank you.
I'm sorry, go ahead.
No, thanks.
Thank you, Daniel. Appreciate it very much, and we look forward to hearing from you again later. We do have quite a few topics to cover in our discussion today, with just about half an hour left, so I do ask all the panelists to keep your answers as succinct as you can. I know we all have a lot to say. We're going to start off by talking about outdoor DAS and small cells. And Paula, I think that you are the right person to give us an outline of the key considerations for carriers as carriers evaluate investments in outdoor distributed antenna systems.
Sure, Martha. I'll keep it short and sweet. Number one, do you have a need? Number two, have you been able to achieve your solution via a macro solution? If no, you have to consider an outdoor DAS or a small cell solution scenario at that point. And one of the most important things is gaining, acceptance from your cities and your munis and your neighborhoods, to install it. And it is not a solution that can be, literally deployed or even thought about as a concept, or even deployed, within 100 days. It's just not going to happen. I've seen them go anywhere from, I think the shortest one I've ever seen has been less than 300 days. And others, it's, you're getting up into 750, to 800 days or more before you can ever put your first node in. So acceptance within the community is your first hurdle that you have to cross. And if you can't if you can't cross that hurdle, I would not start down I would not start down that road, not down that path.
Right. We do hear a lot about that site acquisition process.
It's a big deal. It is a big deal. If you can get past it, though, Martha, you're going to find that, from a small cell or from an ODAS solution, that the communities in where you deployed are going to really love the network that ultimately results from your efforts.
Right. They all want that kind of.
Oh, they love it. I mean, and then it becomes a part of the landscape.
Right. Well, I think that it seems that everyone is looking more carefully at these installations despite the complexities, because the alternative, which is, I guess is getting more out of the macro network, is at times becoming more complex and more costly as spectrum becomes costlier. Philip, do you have some thoughts on that?
Yeah, well, to keep it very brief, if the question is about spectrum, then the answer is yes. I mean, fundamentally, there's three ways to add capacity to a network. You can change the area interface and have a more effective area interface. You can add spectrum, and spectrum is a limited commodity. It seems like it's unlimited, but in fact, it's very limited, and every operator will work diligently to get absolutely every last, in the old day, Erlang, but every data bit and every Erlang of capacity out of that spectral investment that they can. And of course, small cells, and the whole concept of small cells is really the third leg, which is densification. So the reason that we're even having the conversation about small cells in general is because of the need to continue to densify the network to add more capacity, because spectrum and radio technologies are, pretty much at their. There's clearly some new spectrum that are being discussed and some applications for spectrum, but it absolutely makes the discussion about small cells more and more important.
Mm-hmm. Simon, what are your thoughts on this?
Yeah, I think it's absolutely right that there are, you do have to look at the balance between these things, but to make it really simple, if you want to increase your capacity by 4 times to cover a couple of years of growth, if you do that through spectrum alone, it's going to cost you 4 times as much in spectrum. If you do it through small cells alone, it's going to cost you 4 times as much in small cells. If you just double each of those numbers, in other words, you're just doubling your costs, you also get 4 times the capacity. So the best strategy is to get a judicious blend of more spectrum and more cells and, of course, better technology. And the idea that you can kind of substitute spectrum for cells, in my view, leads to a very cost-inefficient solution.
Well, that's a good point. Now, as Paula said earlier, backhaul is and always will be a major challenge. Daniel, I know you have some thoughts on that and some experience there. Can you give us a little more information about the backhaul challenge, specifically with outdoor installations?
Absolutely. So the backhaul can dictate the physical location of a small cell equipment, so that it's very important. And besides the backhaul, another aspect is aggregation. Yes, because you can have like a medium location or a large location will typically have 2 stages of aggregation, per floor and per building. And then there might be cases where the small cell base station cannot be directly connected to the macro cell, and then you'll have to use chaining or trees. So that brings more complex topologies into the picture. And again, as I was mentioning, you can have the situation of home in B or the security gateways, which will add overheads because of the aggregation and the new signaling being added there.
Okay, great. And Scott, what other innovations are you seeing with respect to backhaul?
I think one of the things that operators are realizing quickly is they have to be flexible in the choices of backhaul they may need to deploy to each site. So if you happen to have a cable operator that's within reach of some of the areas you want to work to, maybe that's the best way to wholesale access in there. You might need to use microwaves. You might also need to use whatever other means you have to get to these different locations for backhaul. It's really, in this case, the difficulty is making sure you still have uniformity in backhaul in terms of performance, specifically in places like latency, where if you're using a DOCSIS-based plant, you may have a higher latency than you would over a fiber-to-the-home style delivery. So it's really about making sure that you can still see everything that's going on, especially over a wholesaling network. And there's a lot of different methods that allow this kind of visibility over different kinds of media, but ultimately it shouldn't be the type of backhaul that is used that should be an issue. It should really just be that they all perform equally.
Okay, great. It's interesting you brought up the cable operators. We all know that the cable operators are deploying more and more free public Wi-Fi hotspots. Now, how does this impact the perceived return on investment for outdoor small cells? Simon?
Yeah, so I mean, I think the short answer to the question of whether more free public Wi-Fi, somehow reduces the return on investment for outdoor small cells is no. First of all, the Wi-Fi and the small cells are often sort of led by different people, by ISPs versus mobile operators, and often for different purposes, for, coffee shop or public space environments versus a more general capacity hotspot. And what we do see is in those denser environments, deploying Wi-Fi beyond a certain level does create quite a challenge in managing the quality of service over that network. And we've heard a bit about the tools that you need to manage that complexity, but fundamentally you're dealing with a very best efforts environment in Wi-Fi. And in busy places, LTE works really well, and small cells make LTE work even better. So I think the fundamental ROI for outdoor small cells is still there, and actually the ROI then gets better if you simultaneously deploy Wi-Fi as well. So it's more of an and than an or, I believe.
Okay, great. So LTE small cells are very reliable if you happen to be on the same carrier that those LTE small cells are for. So far, we haven't seen a lot of small cells that can support more than one operator. But Scott, I think you have an example about this happening in South America.
Yeah, there's quite a bit of interest in RAN sharing, not just at the small cell level, but also at the macro cell level to increase coverage over, let's say, a metro region where multiple operators have the radio infrastructure to support full coverage for each other, and you might wonder why would two operators want to share a network of small cells or even macro cells. It's typically if you have a 3-4 vendor environment, 3 operators, 4 operators, the 2 of the smaller ones may team up to create this kind of uniformity of coverage by sharing assets, and it's very cost effective. So we're seeing this quite a bit starting to emerge in Latin America, where LTE has been deployed in a lot of areas but hasn't yet been monetized. A lot of the subscribers aren't actually migrating to it because of the higher price points. They have to really be efficient in how they do this. So I think we're going to see more of this. There's standards in 3GPP and MGMN on how to share RAN resources equitably. And ultimately, it comes down to being able to swap like performance for like performance, and having SLAs between these operators, so they can confidently use other operators' infrastructure without sacrificing their own quality of experience to their users.
Right. Okay. Thank you. Now we're going to move to indoor DAS. Paula, how do carriers evaluate venues for carrier-led DAS projects? I'm sure there are many more buildings that would like a DAS than can possibly get one.
Sure, Martha. So each of the carriers have their own set of evaluation criteria that they use, but all of us pretty much will revolve and pivot around, what is our current coverage and capacity that we have in and around the venue? How is performance today? What's our position in the market? We'll also take a look at the venue itself in terms of size, in terms of age, in terms of ownership, in terms of whether or not the venue is interested in some sort of an in-building solution or a network coverage and capacity solution. And our net promoter scores, from our customers, and a lot of data that goes into the evaluation. It's a 14 or 15 item review for us to make a decision as to whether or not, that we will pursue a venue. So it's a lot of common sense type of questions that we ask. So that's pretty much, without going into a lot of the science and a lot of the formulas behind it. That's what goes into it.
Right, and I know that you've talked in the past about how the network architectures are an important part of the decision as well, CIPRI particularly. Simon, I think you have some information that you want to share with us on the evolution of network architectures for in-building deployments.
Yes, I do. So I said earlier on that when you're deploying a DAS and then you want to increase the capacity, you can run into some challenges, and there's a lot of innovation going on amongst DAS vendors today to move to a more of a digital DAS environment and to be able to flexibly allocate capacity to different places, which is very helpful. When you look at that digital DAS architecture, with radio heads on the edge of the network and a digital LAN essentially in between the two, actually it looks almost identical to the CIPRI-based CRAN architecture. So we're seeing a sort of coming together of the CRAN and DAS environments into that situation. And the real issues there are not whether we should move digitally. We absolutely will and are doing so, but actually what we have to do around interoperability to make this work as well as it can. CIPRI is a great potential interface, but it's really not interoperable, and it doesn't give us much choices about using different piece parts from different vendors, for example. So we need to extend that. We need to be able to control it. But if we can do that, then we can really make things both more flexible but also more cost-effective. And our evaluation recently of a CRAN-based small cell solution for both small and large office environments meant that we found even in a multi-operator environment, we could build a CRAN-based small cell solution for 44% lower cost than the equivalent service from a multi-operator DAS. So it's very important to evaluate which architecture fits best with a given building these days.
And approximately what size of building was that you came to that result?
Yeah, we looked at a variety of buildings, a smaller building of about 100,000 square feet and a much bigger building at about 600,000 square feet. And, the specific numbers vary, but the cost savings were substantial across both of those environments.
It sounds like it. Now, once these are deployed, the cost savings, I think, have a lot to do with troubleshooting effectively, and that has a lot to do with network visibility. Scott, do you want to comment a little bit on the importance of network visibility for keeping those costs under control?
Well, there's actually a mix here of things that need to be done to make sure that a DAS will work properly. It's a bit more difficult than a standard outdoor small cell deployment, because here you have the front haul that we've been talking about that in many cases it's either RF or it's going to be CIPRI or something that's really not something you can analyze easily with Ethernet type equipment. So in this kind of environment, there's a strong need for some sort of air interface probe that can actually take the experience of the customer straight off the network. And often these types of, let's call it an air module for some better word, something like a small smoke detector sized object that can be placed at different locations throughout a building or a stadium or some large venue and monitor what's happening from the user experience perspective. So that would all get rolled up with the backhaul type monitoring to give you more of an end-to-end view so you can isolate issues. But I guess the real value of having a stationary probe-based point as opposed to installing software on users' phones is that you take out a few elements out of the picture. So you're not adding mobility into the mix, really analyzing the, let's say, data download speeds, latency, things that you can quantify and compare to other upstream type metrics.
Okay, thank you. Well, we've already heard a little bit about making choices between DAS and small cells, and Philip, I know that you've told me before that there's competition between those two technologies. Paula, can you give us a little bit of information about key considerations for carriers as you evaluate venues for indoor small cells?
Martha, it's a wonderful thing about evaluations, in a network, is that you start at a very high level and you work your way, down to the lowest level to determine what your best solution needs to be. And so it's much about the same, is it going to be a public solution, meaning that, everyone in a building or a venue will be able to access your product? Or is it going to be a proprietary product, meaning that it's an enterprise product where it, for example, it might be only AT&T customers that are able to access. So you go through that. Once again, the landlord or the building owner is also a very integral part of what has to happen here. A lot of times it's about the tenants in a building as to whether or not that we're going to, that access is going to be granted, in order to build out the necessary infrastructure that's there. And it's also about how much of the building is actually going to be a part of your coverage play and therefore your capacity play. And what we do is, we find the economic crossover point for the best solution that delivers the best experience for our customers and at a price point in which we're willing to pay.
Right. Now, I do think that we're hearing some about businesses that are stepping up to pay for their own infrastructure in some cases. Simon, are you hearing that as well?
Yes, I am. I mean, we've been looking at the business case for enterprise small cells, both from the carrier's point of view, but also from the enterprise point of view. And I must say, in general terms, it's a really easy business case to make. The benefits for both sets of parties are absolutely huge. But nevertheless, the number of enterprises that actually get a solution is a tiny proportion of those that actually want it. And I think part of the way of kind of solving that conundrum is coming up with ways that that help the crossover point that Paula was talking about by encouraging enterprises to dip into their pockets for some of the funding on this. But in order to do that, they need to feel that this infrastructure is part of their enterprise environment. And we see a rather small number of carriers that get that and are coming up with new models for deployment, which involve more of a partnership with their enterprise customers, and recognizing that you can build the smarts into the small cells so that your network is protected. But sadly, still today, most carriers still seem to be in a mindset that every building is a special project requiring a lot of hand-holding. And I'm afraid that just doesn't scale. So I think the carriers, and there are definitely some that get the need to evolve the model, will clean up in a fairly big way and delight their enterprise customers in the process.
Well, certainly there's a big need out there. Now, we do need to talk a little bit about unlicensed spectrum because that's developed recently, and we're hearing so much about that as a way to deploy more LTE. Philip, I know you've told me that's come up in a lot of your conversations.
That's right, Martha. So there is a lot of industry talk and a lot of, and actually it's a lot of technologist talk about the implementation of LTE and unlicensed bands. And so a lot of the question here is really because question. Most of this is still early days in terms of how well the technology works, and really the one question that will continue to need to evolve and be resolved is the comfort level that the carriers will have with launching LTE in an unlicensed band. This whole question of licensed versus unlicensed and what the ramifications of that may be. But nonetheless, the real key here is that most of the discussions about using unlicensed spectrum for LTE are really a question of carrier aggregation. And there's been some good trials. There's some trials that indicate that there is a pathway to some capacity gains through carrier aggregation using the unlicensed band to help supplement the licensed band in certain applications. Now, how that will affect small cells, will it create more demand or less demand? Honestly, I think that's still in front of us. The logic of it would be that if you are able to solve some of the frequency access problems and use that additional frequency to solve more of the capacity problem, then it might mean that you need fewer small cell nodes. So that's one possible outcome. But again, so much of that is in front of us that we still need to continue to evaluate exactly where this technology goes.
Right, and Paul, I'm sure that AT&T is keeping a close eye on that, right?
Absolutely.
Definitely. Well, before we move into our last slide, I do want to let everyone know that we will probably not have time for audience questions. However, if you do have questions and you type them in on your GoToWebinar control panel, we can see them, and we can share them with our panelists after the webinar, as well as your contact information. So please do submit your questions if you have them. And at this time, we're going to move on to talking about optimizing performance for indoor small cells. This is so important. Daniel, can you give us a little more information about why assurance and optimization are a little bit more challenging indoors?
Sure, Martha. So the small cells, the indoor small cells, bring in new aspects to be validated and optimized. Yeah. For example, macro offload and load balancing, that's the cell selection procedures, or handing from macro cells to the small cells, that's the primary scrambling code management, or the neighbor management, yes, the macro recognizing the small cells for handoff. So right there you have a couple of challenges moving from the macro to the small cells. And then let's not forget the indoor small cells are seen as sometimes are seen as the solution for fixing poor voice coverage and quality, so there are high expectations. One more aspect, it's location services. Let's not forget FCC has proposed rules to set the target to improve location accuracy for indoor 911 calls within 50 meters. So dense small cell networks, the key is to make sure interference is managed, mobility is robust, and reliable and consistent user experience is delivered.
Great. Okay, well, indoor, obviously, Wi-Fi is something that's always, or almost always, part of the picture. Scott, can you give us a little bit of information about how Wi-Fi networks can impact small cells, and also how carriers can prepare for the eventuality of voice calls over Wi-Fi?
Yeah, these are interesting issues here. I think some of the main parts of small cell communication or main aspects have to be regarded in small cell networks in terms of performance is that they're often sharing the corporate LAN as a method to backhaul out to wherever the next destination may be, and this could be a concern for the operator because they may be backhauling over even the open internet as it goes back, or the customer's connection to the internet, for example, as opposed to their own connection. So you're talking about an uncontrolled environment to some extent. And once you get inside the corporate LAN, now you have quality of service issues potentially if prioritization in the network and the ability for different traffic types to coexist seamlessly that doesn't get set up properly in that infrastructure. So the IT group in the organization is going to necessarily have to cooperate to make sure that the small cells get the priority on the traffic versus, let's say, Wi-Fi for certain critical applications, and that would certainly be true for voice. I guess the other main aspect here is when you're talking about future-proofing, it's largely related to the same kind of aspects of having enough backhaul bandwidth within the walls of the company to make sure that these new applications come in and maintain their priority on the network. And you can do that with pre-assessment tools. Of course, you can actually simulate the load that VoLTE or voice over Wi-Fi would have on the network by creating synthetic streams very cost effectively and very simple process. And you can also see the quality of experience metrics like MOS score and predict how it would look over existing network traffic in the background. So the goal here as best practices would be when you're deploying your first small cell deployments, anticipating these new services coming, is that you should simulate those services at the get-go so that you can ensure that the backhaul doesn't have to be retrofitted or the front haul inside the company wouldn't have to be optimized later. So you know that these are things you can light up without having to revisit the site.
Yeah, that does sound expensive. All right, Scott Sumner, CDN Networks, thank you very much. Well, at this time, I'd like to thank all of our panelists for joining us today. Paula Devlin of AT&T, do you have any final thoughts to share before we say goodbye?
No, Martha. Just thanks for asking us to participate today, and I hope everyone has a wonderful, wonderful day.
Thank you. I hope you do as well. Simon Saunders has provided our analyst commentary today from Real Wireless. Simon, thank you very much for being here. Do you have any final thoughts?
No, just that what we're dealing with here may seem a diverse set of topics. Sometimes hard to connect one to the other. But what we're really doing through HetNets is completely re-engineering the radio network to make it fit for the future. So it's worth the time that we spend on it on discussions like this.
And we hope to have more of them. Thank you. Scott Sumner is VP of Solutions Development and Marketing at Heterogeneous Networks. Scott, thank you very much for joining us.
Thank you, Martha, and I'd really like to thank Simon and Paula for their wider-ranging views on things coming from more of the provider side, implementation side. It's very consistent with what we're seeing with many of the customers we work with, and it's just so I think the webinar here adds a lot of value to other providers that would be watching today.
We do appreciate their participation very much. Philip Sorrells is Vice President of Strategic Marketing at CommScope. Philip, it's always great to hear your perspective. Do you have any final thoughts?
Well, Martha, I just say again that ultimately this conversation about small cells is about densification. It's really about how do we add more sectors, how do we add more cell sites, be they smaller, be they more precise. It's really ultimately about that. That's how we add capacity, and that's how we've done it for the last 30 years, and I'm sure how we'll do it for the next 10. In all this conversation, one thing that we didn't talk about was as you add densification, you also have to always be aware of SINAR. LTE is interference limited, and we've got to always stay on top of what the interference and noise levels are in the network, or none of these cool tools actually work. So very important fundamental.
Well, thank you for that reminder. That's right. Okay, and Daniel Musat, Senior Technical Marketing Engineer at Ixia. Daniel, it was great to have you on the webinar. Do you have any final thoughts to share?
Thanks everyone for joining. It was a great discussion, I believe. Looking forward to the questions.
Great. Well, thank you all very much. I'm Martha DeGrasse with RCR Wireless News, and this will conclude the webinar.